Okay, so my video program only allows me to do videos for 15 minutes, so I was right at the end as we were finishing this problem. But just to kind of highlight again, hopefully you're seeing the different connections here between the long division and where the same values, coefficients are showing up in that as they do in the synthetic division. So hopefully that gives you an idea of the connection and how synthetic division can kind of speed up the process of dividing certain types of polynomials. So here's our next problem. If you would like to pause the video for a moment and try this, go ahead and do so. And then I will work it out here momentarily. So once you think you have the problem, you can start the video back up. So in dividing here, we're going to use a positive 4, changing the sign of what was in our binomial there. Our coefficients, we've got 2, -5, 3, we've got 0, -11, and +1. Let's see. Nope, I need, yeah, that's right. From here, we'll draw our line, bring down the 2, and multiply. So 2 times 4 gives us 8. We add those two values, -5 and 8, which gives me 3. And we're multiplying. 4 times 3 is 12. Add, get 15. 4 times 15 is 60. Bring down that 60. 4 times 60 is 240. -11 plus 240 is 229. And then 4 times 229 is 916, leaving 917 as our last value there. So we've just found the coefficients. Now we just need to assign the correct variables to each, remembering that we need to decrease the degree of each of these by 1 from what they were in the original problem. So we have 2x to the 4th plus 3x cubed plus 15x squared plus 60x plus 229 plus our remainder of 917 divided by x minus 4. Alright, so hopefully you got that one. So one of the purposes in doing all this is to help us understand how we can identify factors of a polynomial. And so we have a rule that basically says that if we take a polynomial and divide it by another polynomial and the remainder comes out to be 0, what that means is that value that we divided by is a factor of the other polynomial. And so this is going to be helpful later on when we're looking at graphing polynomials and identifying zeros. But for right now, what I want you to practice here is take this polynomial, divide it by x minus 3 using synthetic division, and see if you get a remainder of 0. If you do, that means that x minus 3 is a factor of our polynomial. If the remainder is not 0, that means x minus 3 is not a factor. So I'll give you a moment to do that. Maybe pause the video and then start it back up when you need to. Okay. Okay, so hopefully you got the same values below the line as I did. The key one being this last one of 0. And so if that last digit is a 0, that means the remainder is 0, and that tells us that x minus 3 is indeed a factor of this polynomial. So for our purposes now, that's what we're concerned with, is saying that x minus 3 is a factor. Now, if I asked you what would be the polynomial that's left when we divide by x minus 3, that would be 2x to the fifth plus 6x to the fourth plus x plus 3. Okay. All right, here's your homework assignment, page 983, numbers 7 through 43, and you're doing every other odd problem there.